Okay, so this is lesson 2. In lesson 2, you should have already done the opening exercise. Okay, I'm always going to start with the opening exercise. You should always try and do it on your own first. For the 3 lines that we've got up here, I color-coded them so you can see them all at once. In the blue one, it says that the y-intercept is going to be 6, so that's why we started off here. And the slope is 2, so you go up 2 over 1, up 2 over 1. And then in the opposite direction, down 2 over 1, down 2 over 1. And you're going to do the same type of thing for the other 2. And your line should look like this. If you have any trouble with those, then you should put the equations in y equals on your calculator. And then when you go to the table, you'll see the points and you could plot from there. So something that you might notice about the slopes is that for the blue line and the green line, they actually have the same slope. You've got 2x here and you've got 2x there. And that is going to have a lot to do with why they look the way they look. So if we look at part A, it says, what do you notice about the slopes of M and H? So M and H are the blue and red lines. And for M and H, we've got slopes of 2 and -1/2. So those slopes are different, so that means they're going to intersect. Okay, you can see right here, they cross. So that means, yes, they intersect. But if you look at M and K, which is the blue and green lines, they both have the same slope. They both have 2. And they do not intersect. That's because they're parallel. And parallel lines are always going to have the same slope. Now, I've mentioned that in the past. I've talked about how parallel lines are going to have the same slope because they're going to be going up and over the same amount, so they're never going to cross each other. But this is kind of putting that into words and making rules out of it. And if you look carefully, these ones, the 2 and the -1/2, when they cross right here and also right here, that is going to look like it's going to be 90-degree angles, and there's actually a rule for that too, and we'll talk about that in a little bit. So some general things that we're noticing here is that if they have the same slope, the 2 lines are going to be parallel, just like M and K, the blue and green ones that we did up here. Same slope, they're parallel. So the M value that you've got in your equations up here for y equals mx plus b, if this is the same number, then that means that they're going to be parallel. Also, if the slope is positive, which you have for the blue and green lines, that means that your line is going to be going up. If it's negative, like it is for the red line, see how it's a -1/2, then that means your line is going to go down. The next part, it's going to put some of these into actual rules that we'll be able to definitely use for this point forward. So the parallel lines will always have equal slopes. So I am going to write it like this. Parallel lines are like that. We've used that in the past. But the slopes, represented by M, are going to be equal to each other. Now notice how parallel and equal kind of look the same. That's maybe a trick that you can remember to show that those things are always going to be the same. Now, perpendicular lines, perpendicular, the symbol looks like this. That means that they cross at 90-degree angles. They're always going to have negative reciprocal slopes. Now, negative reciprocal. Negative means that you're going to multiply your number times -1. So if it's positive, it's going to become negative, and if it's negative, it'll become positive. And then reciprocal basically means you're going to flip it upside down. So the numerator becomes the denominator, and the denominator becomes the numerator. So, for example, if you had 2, the reciprocal of that means you're going to swap the 2 over 1 and make it 1 over 2. And if it's the negative reciprocal, you're going to make it negative. And we're going to do a couple more examples in the next part here. But the way I remember perpendicular being a negative reciprocal is that the perpendicular symbol that we've got, this, kind of looks like this. Okay, and if we use generic terms for that, if we said that the slope is going to be to the negative reciprocal of it, you still have that same perpendicular type thing up there. So if you can remember that it's a negative reciprocal, you don't need the little tricks. But perpendicular lines are always going to have negative reciprocal slopes, and parallel is always going to have equal slopes. So for this first part, we're going to write the negative reciprocals for each of these. So that means you're going to flip it, and you're also going to multiply times -1. So the reciprocal of this means you're going to swap the 2 and the 3. So 2 is now going to be on the top, 3 is going to be on the bottom, and we're going to make it negative. For the next one, it's already negative, so we're going to take it and we're going to make it positive. We're just changing the sign. And then we're swapping the numerator, which is the top, and the denominator, which is the bottom. So it's going to be 5/4. And if you don't want to put the plus sign, you don't have to. If it doesn't have a negative sign in front of it, we're assuming that it's positive. -1 is really -1/1. If you have just a number by itself, you could always put it over 1. So when we swap this, it's going to be 1/1, and this negative becomes positive. So our answer for this one is just a +1. And then 4 is really 4/1. So that means the reciprocal is going to be 1/4, and the negative reciprocal is going to be -1/4. So if we had 2 lines and we had y equals 4x plus some random number, and we had y equals -1/4x plus some random number, that means we know that just by looking at this part right here, since those are negative reciprocals, if they're negative reciprocals, we know the lines are perpendicular. Okay, that's all we're getting from this. So the second example, it says determine if these 2 lines are parallel, perpendicular, or neither. So if they're parallel, that means the slopes are going to be equal to each other. Okay. If they're perpendicular, they're going to have negative reciprocal slopes, kind of like what we did here. And if it's not either one of those, then that means they're just going to cross at some other angle, like this. Looking at these 2 equations, it's kind of hard to compare because they're not in y equals mx plus b form. Our first step is going to make them both look like they're in the same format. So for this one, to make this one in y equals mx plus b form, we have to get rid of the 3y and just make it y. So let's divide both sides by 3. So the 3's cancel out, and we've got y equals, and then we're going to do this separately. So this part over here is going to be 2/3x, and then we're going to divide again because we've got a plus sign in the middle. If you have plus or minus, you can separate it. If you've got multiplication in there, then you have to do it all in one step. Like 2 times x is paired together, but we can do this separately when we've got plus or minus in the middle. So +9 divided by 3 is 3. So by rewriting that equation, this is equal to this that we had up here. So I'm just going to clear that up a bit. There we go. And then this one I'm going to rewrite over here. We've got 2y equals 15 minus 3x. We're going to put the 3 in the negative 3x in the front because we want y equals mx plus b. So the x part goes before the number part. And it's a +15. And we're going to get rid of the 2. So we're going to divide on both sides. So y equals negative 3 over 2x for this part. And then we're going to do the same thing over here. And that's 15 over 2. You can leave that as a fraction if you want. Or you can divide it and say, okay, that's 7.5. But I'm just going to leave it as a fraction for now because we don't care about what the end part is. We're just going to compare the slopes. So if we look at the slopes for the first equation, it's 2 over 3. And then for the second one, it's negative 3 over 2. Now comparing those, 2 over 3 and negative 3 over 2, are they the same, negative reciprocals, or neither one of them? That's what we're looking for. So they're definitely not the same, which means they're not parallel. Negative reciprocal means that we're going to swap the top and the bottom and change the sign, and that's what we did. We took the 3, moved it to the top, the 2, moved it to the bottom, and went from a positive number to a negative number. So, since they're negative reciprocals, that means they're going to be perpendicular. So these two lines, this one and this one, also represented by this and this, are going to cross and make 90-degree angles. Now we're going to do something very similar with this next one, okay? Except now we're going to twist the order around a little bit. So we're going to write the equation now, knowing that it's going to be perpendicular. So it's going to be perpendicular to this line, so that means we're going to first put this in y equals mx plus b form. Then we're going to figure out what the slope is. And then we're going to do the negative reciprocal of that. Then that's going to be our slope. And when we've got the slope and a point, then we can use our point slope formula from lesson 1, which is this. So if you think you can do that on your own, then pause the video and try it on your own, and then watch me go over it, maybe in double speed or 1.5 speed, so that you can see all of the steps that I'm doing. And if you're not sure how to do it, I'll walk you through it. So we're going to start with putting it in y equals mx plus b form. So this equation over here, we're going to make it so it's y equals, so we have to get rid of the 6 on the one side. So let's, delete it. We'll have to divide both sides by 6 because it's 6 times y. So we're undoing that multiplication, get y by itself. So we're going to have 5 over 6x plus 72 divided by 6. And 72 divided by 6 is 12. And the slope here is 5 over 6. And we want the negative reciprocal of that because we want something that's perpendicular. So the reciprocal means we're going to flip it. And now we have 6 over 5. And we're going to change the sign to make it the negative reciprocal because we want something that's perpendicular. So this is going to be m in this equation. Now the other things that we need for that equation is going to be y1 and x1. And that's going to come from the point that we had before. So 5 is x1, negative 12 is y1, and the slope is negative 6 over 5. And we're going to plug that all into this equation. So y minus a negative 12 is going to be plus 12. The slope is negative 6 over 5. And then for the x, it's going to be 5 from right here. So we're going to distribute this fraction to both pieces here. So this stays the same, and then negative 6 over 5 times x, and then it's going to be negative 6 over 5 times negative 5. So the negatives are going to cancel out and make it positive. And the 5s are actually going to cancel out too and just make it 6. But if you wanted to do it in more than one step, 6 times 5, right here, 6 times 5 is going to be 30. And then when you divide that by 5, you're going to end up with 6 again. But if you do that all in your calculator all at once, then you're going to end up with the same answer. And then we're going to get y by itself, so we're going to subtract 12 from both sides. And this is our answer. So this is the equation of a line that is perpendicular to this line and goes through this point. So we've done quite a few things here. We've come up with a line that has a perpendicular slope, and we've decided that that line is going to go through this point. Because if you've got a line that looks like this, say that this was this line. If you want a line that's perpendicular to it, it could be here, it could be here, it could be anywhere, as long as it makes 90-degree angles. So we're choosing the one that's going through a specific point, so we know it's going to be this line, and that's our answer. So that's why we are very specific for this. Okay. The next part is asking, what would you have done differently if this one that we just worked on said parallel instead of perpendicular? The only thing we would change is that this part right here, we wouldn't try and do the negative reciprocal. We would try and make it the same slope. Because if we look at our rules, parallel lines have equal slopes. So instead, we would have m be equal to 5 over 6 from right here. And we would use the same x1 and y1, and it would look like this. Okay, and then you could solve it that way and figure out what the equation is based on that. So this is the only thing that would change, just the slope. Okay, so this next question is basically that. So you guys pause the video. I want everyone to try and do it. Okay? Plug in and solve. Okay, so since this is the same question, except now saying parallel, you're going to use this. Right? That's the same thing that we just talked about up here. It's all the exact same numbers. These are the same, this is the same. If you wanted to redo this and figure out that it was still going to be y equals 5 over 6 x plus 12, that works too. And then this is going to be the same slope. You know, it's the same process, but once you get to here, then you're just going to distribute and put it in y equals mx plus b form. So y plus 12 stays on the left, and then you're going to distribute the fraction. So you've got 5 over 6x, and then you're going to multiply the fraction times negative 5, so you're going to have negative 25 over 6. And if you wanted to change that into a decimal, you can, because when you subtract the 12 over, we can just change it to a decimal, and that works fine. But we're going to keep the slope as a fraction. So when you subtract the 12, you're going to get negative 16.16, and then the 6's repeat. So that's going to be our answer for this one. Okay, it's the same process. You're going to figure out what the slope is, you're going to find what the x1 and y1 is going to be, and you're going to plug into the formula. example 5 is the last problem that we're going to do. And we're going to plot the points of the square. And we're going to try and figure out the equation of the line that would be the other diagonal. Okay? The important part of this is that you need to know that the diagonal lines in a square are going to be perpendicular to each other. Okay? That's something that we learned a few units ago when we started doing parallelograms. So when we plot these points, B is 1, 2, so that's going to be here. A is 5, 2, which is here. S is 5, negative 2, and E is 1, negative 2. So this is our square. The diagonal that contains SB, right here, is this equation. And that makes sense with what we've got because it crosses at 3. And our slope is going to be down 1 and over 1. Okay, our slope here, although it doesn't say it with numbers, is negative 1 over 1. So that means you're going to go down 1 over 1, down 1 over 1. So we're going to figure out the equation of the other line. So you can do this graphically if you want to, or you can do algebra like how we've been doing. So I'm going to show you the algebra way first, and then I'm going to explain the graphing way as well. So the slope is negative 1 over 1. We know that if we're going to do the other diagonal, it's going to look something like this, connecting the other 2 points. It's going to be perpendicular. The slope of diagonal lines in a square are always going to be negative reciprocals because they're perpendicular. So the negative reciprocal of negative 1 over 1 is going to be positive 1 over 1. And then we know that it's going to go through both of the points in the middle, these 2 points. So you can choose one of those and make that your x1, y1. So in this case, I'm going to choose A because that's got positive numbers and that might be a little bit easier for us to plug in. So if we do y minus y1 equals m times x minus x1, then we've got that. We know that m is going to be 1 over 1, which I'm just going to plug in as 1. And then for a, this was the point 5, 2, so that means the x value is 5 and the y value is 2. And when you distribute everything and solve, you're going to get this as your answer. Y equals x minus 3. And if you were to plot that, negative 3 is right here, and then rise 1 over 1, repeated over and over again, we're going to have this as our equation. If it goes through both E and A, that means we are correct. And it looks like that. Now, most of you guys would probably be able to figure out how to do that without doing an equation. But that's just because this is a square. It's a little bit easier to do it for a square because you just connect the 2 points. But if it was something that was a little bit more complicated and you didn't have that much information, this is the way you would do it. Now, that would work if you did it with E instead. It would work if you decided that you were going to use this point, knowing that the diagonals of a square are going to be perpendicular bisectors of each other, so the middle of this line would also be a good point to use. Or you could just connect E and A and then figure out what the equation of this line is based on counting boxes, and doing the slope-intercept formula just like you used to do. So whatever way works for you is going to be fine, unless if it told you a specific way to do it. If it said you have to use the point-slope formula, then you have to use the point-slope formula. But if it doesn't say how to do it and you just need to come up with the equation, then do it whatever way you think is best for you. Now, the homework for this is going to be 2 pages. So you've got this page, and then you've also got this one. It's only 4 questions, though, even though it's 2 pages. This one takes up a whole page because it has a graph on it. What I want you to do with it is I want you to turn it in on Classroom, just like you did for the lesson 1 homework. Okay, turn it in on there, and I'll give you credit for it. It's going to boost our grades. Again, I'm going to be checking that you are doing your best for it. If you're not completely accurate, you're still going to get credit. I just want to see that you're trying for it.